Hey everybody, Mr. Bells here again. This video is for Precalc A, chapter 2-5. This is end of January 2021, and hopefully this will be really beneficial for you. So I'm going to talk a little bit about what it's going to be on this video. I'm going to try and start maybe hopefully organizing these a little bit more. So we're going to look for given zeros or factors of polynomials, whether they're real zeros or they're imaginary zeros. How do we find those polynomials? How do the graphs kind of look like those ones? And then being able to, given a polynomial in standard form, can we find all the zeros real and imaginary, both with technology and without technology? So I'm going to cross my fingers for you on this one, and here we go. Okay, we're going to start off with this right here. So I've got these three factors, so x times x plus 2i times x minus 2i, and we're trying to find the polynomial in standard form from this. Well, you know that you could just multiply these two things together, and just kind of a reminder, if negative 2i is a solution, which this would be a solution to it, then positive 2i would also have to be a solution to it, because imaginary solutions have to come in pairs, complex conjugates. So if 3i is a solution, then minus 3i is a solution. If 2 plus 4i is a solution, then 2 minus 4i is a solution. They have to go that way. Okay, so let's start with some basic math here. So that's x squared, and then the outside is negative 2ix, and the inside is 2ix. And those two things will cancel. And then you'll get minus 4i squared, right? 2i times negative 2i is negative 4i squared. You guys remember imaginary number squared is actually negative 1, so this term becomes x squared plus 4. And then, if I take this and I multiply it by x, which is the first term, my new polynomial, we can call it y or f of x, I'm not really too concerned about it, is x cubed plus 4x. And supposedly, those are all my zeros of my polynomial. Well, let's do a quick little picture here and make sure that you guys are kind of on top of this stuff. Again, you don't have to do what I'm doing right now. I just wanted to show you. So I'm going to go to my y equals, and I'm going to go ahead and type that in, x cubed plus 4x. X cubed plus 4x, and there we go. And then zoom 6, there's my viewing window. So you can see indeed it does go through 0, that's one of them. But it doesn't touch any other place, so that means the other ones have to be imaginary solutions. So let's go to our home screen and try this. So I believe, according to this, that my zeros are 0, negative 2i from this one, and positive 2i from this one, because remember, it's what makes the inside of the parentheses 0. Those are my three zeros to the function. So let's try this. 2i, store it in x. There we go. And now I'm going to type in this actual polynomial, x cubed plus 4x, so x cubed plus 4x. And when I hit enter, it should say 0. Look at that, it does. So that means that 2i is definitely a 0 of the function. Okay, now I could do that for negative 2i, and I could also do that for 0. It would all work. So one more time. If these are factors, which they are, these are the zeros from these three parts. And if I multiply those all together, I can get a polynomial in standard form. Standard form means there's no parentheses in there, that everything's been distributed out. Okay, so let's do the same thing for something a little bit more complicated down here. So I know my zeros. Let's go ahead and do that first. My zeros are 4, negative 2. So those are the two real places that it's going to touch on the x-axis. And then negative 3i and positive 3i. So those are my four zeros, which means this has to be a degree 4 polynomial or a quartic. So let's go here first. So I get x squared minus 2x minus 8. That's one polynomial. Here, I think you'll get better and better at this. So x squared, the insides and the outsides happen to cancel on this one again. Doesn't mean that they have to do that every time, but they do in this case. And then 3i times negative 3i is negative 9i squared. So that's plus 9. Okay? Now I'm going to multiply this times this, and I get x to the fourth minus 2x cubed minus 8x squared. And I'm going to do the 9 to each one of those things. So that's 9x squared. I'm going to line these up. Minus 18x, and 9 times negative 8 is negative 72. So there we go. So my polynomial is x to the fourth minus 2x cubed plus x squared, or plus 1x squared. I don't care if you really want to write the 1 or not. Minus 18x minus 72. Good deal. Now, if you take this and you put this into your graphing calculator, you will see that it does cross at 4 and negative 2, and that's the only real places that it crosses. However, I believe that the other two imaginary solutions are negative 3i and positive 3i. Okay? So I'm going to come back to this one in just a second, and hopefully that will be okay. So next thing I'm going to do is I'm going to say this. Sometimes we have zeros with multiplicities. So I'm saying that negative 2 has a multiplicity of 3, and 4 has a multiplicity of 2. What might a possible graph look like? Well, if I was to write out my zeros, just want to make sure that you guys are okay in understanding this. That means I have a 0 of negative 2, of negative 2, of negative 2, of 4, and of 4. 3 multiplicities, that's what my M3 represents, and 2 multiplicities, that's what my M2 represents. Well, we know that if it has 5 real zeros, that means that this polynomial has to be an x to the fifth. We know, if we look at the graph, it's got to go through at negative 2, and it's got to go through at positive 4. Now, I haven't told you anything about the leading coefficient. I haven't given you any other things on it. So, if I had a polynomial graph that looked like this, do you agree that this could not be that graph? Because this one has 3 real ones. Good deal. That's one reason. Also, we know since there's a multiplicity of 2 at this 4 spot, that it actually has to bounce at that 4. And since there's a multiplicity of 3 at the negative 2 spot, it has to whoop whoop, right? That's our technical term. Whoop whoop at that location. So I know from general sense right now, since that's a multiplicity of 3, I know that this has to come up and do the little whoop whoop right there. And whatever happens here, I don't know, because I don't know enough about it, but when it comes down to 4, it's got to go like that. Now again, our graph would look like this if, one more time, big if the leading coefficient was positive. If the leading coefficient is negative, then this would happen, right? This would go like this, right? And that would go like that. So the red is if the leading coefficient is negative. The black is if the leading coefficient is positive, just knowing from these multiplicities. So just hoping that you can kind of tell from those things what the heck's going on. Okay, so now I'm going to move to this next thing. Can I find all the zeros, and can I factor this thing all the way out from this thing right here? And this is where we're going to get to, and this is going to start to become a little bit bigger. But I'm going to show you something first using the ones that we already know, right? Those are all our factors. Those are all of our factors. And I'm going to use this thing right here. So let's pretend, play pretend for just a second. Let's pretend that I was given this polynomial and I didn't know any of this other stuff. I just have this polynomial. I know that I could go like this on my calculator. Y equals, clear, x raised to the fourth minus 2x cubed plus x squared minus 18x minus 72. And I know that's a fourth degree polynomial with positive leading coefficient, so its end behavior is going to go up like that. I go ahead and hit zoom 6. And I can look at the graph and see pretty obviously that negative 2 and 4 are solutions or zeros to this polynomial. Yay. Now, Does that match what it said right here? Yes, but remember, we're going to pretend that we didn't know anything in this red at this point, okay? So I graphed and I found those two. Now I'm going to use synthetic division with those two zeros to see if I can reduce this thing. Now just a reminder, we know that all the possible rational zeros are all the factors of 72 divided by 1. Negative 2 happens to be a factor of 72, so I'm going to go ahead and do this. So I got 1, negative 2, 1, negative 18, negative 72, and I believe this better be a 0 when I go through and do this synthetic division. 1 times negative 2 is negative 2, that's negative 4, that's 8, that's 9. Negative 2 times 9 is negative 18, that's negative 36, that's positive 72. That's a remainder of 0. That's a big ol' honkin' smiley face. But again, I knew that it was going to work. But here's the cool thing about this. Because I just really divided by x plus 2, right? That's what a minus 2, 0 is. I've also changed this polynomial from a degree 4 now to a degree 3. I also believe that 4 is going to work, and I don't need to do 4 on my original one. I can do 4 on what's left over. Okay? So, here we go. Bring the 1 down. 1 times 4 is 4. That's a 0. 4 times 0 is 0. That's a 9. 4 times 9 is 36. That's a remainder of 0. That's another smiley face. I know that that works. Good deal? But, more importantly, if you look right here, you can see that that's the polynomial that's left. Now, I can't get it from my graph. Because you can see there weren't any real solutions, which means that this polynomial that's left must be what we call an irreducible quadratic factor. Okay? So it's quadratic, x squared plus 9. X squared plus 9 happens to be what's left. Good deal? Now, at this point, I have 3 options. If I want to find the zeros to that polynomial, that quadratic, I can use the quadratic formula. I can use completing the square, or because this particular one has no linear term, I can just use basic algebra. Okay? So I'm going to go ahead and do that. Solve x squared plus 9 equals 0. X squared plus 9 equals 0. Move the 9 over. X squared equals negative 9. Root it. X equals plus or minus 3i. Oh my gosh, look at that. There's my negative 3i and there's my positive 3i factors. Those are my 2 other zeros. So I was able to, pretending not knowing this, start from here and find all of the zeros from it, which is what we're going to try and do right on this one. So step number 1 for you guys. Turn it on, go to y equals, clear, because I didn't give you any of the information to begin with. So we're going to try x raised to the 4th plus 2x squared minus 24. And I'm going to hit the graph. You can see again there's only 2 solutions that are here given, negative 2 and positive 2. Now how do I know that they're actually on those 2 spots? Because it could be just really, really close. 2 things kind of tell me that. 1, these are all nice even numbers, so there's a good chance. But if I go to my table setup and look at those tables, you can see immediately I can really check that those are both zeros. Okay? So I know that negative 2 and 2 work. So I'm going to put those right here. And I'm going to do synthetic division. Doesn't matter which one I start with. So here's my synthetic division. 1 for the x to the 4th. 0 for the x cubed. 2 for the x squared. 0 for the x, because we have to put in placeholders. Minus 24 for the constant. Bring the 1 down. 1 times 2 is 2. 2 times 2 is 4. 6, 2 times 6 is 12. 12, 2 times 12 is 24. Remainder 0. Yay, it worked. Now again, I don't want to do it with my original, right? I've shrunk my original down to this one. So now I've got 2. -2 to try. So here we go. And now I better get a remainder of 0, because again, we already saw that it touched. But what I'm able to do now is I'm going from a degree 4 to a degree 3 to hopefully to a degree 2. And you guys know that with degree 2s, we can use completing the square quadratic formula every time to solve that. So bring the 1 down. -2, 0, 0, 6, -12, remainder 0. And you can see here that I'm left with x squared plus 6. Yeah? So what are my other zeros for this one? Again, I don't have a linear term. Probably should have given you one with that. Maybe I'll show you a quick little review on it if you have one like that in just a second. So that becomes x squared equals -6, root it, x equals plus or minus I root 6, because the square root of 6 is not a nice number. So what are my zeros? My zeros are -2, 2, I root 6, and -I root 6. And you can see the imaginary ones had to come in pairs. Yay! My factors are then x plus 2, x minus 2, x plus I root 6, that's for that one, and x minus I root 6 for that one. And surprisingly, as it may seem, if I multiplied those 4 things together, and I took the time to do that, I would get x to the 4th plus 2x squared minus 24. Okay, so what I've just now shown you is how to be able to, if I have a graphing calculator, and I know that I have some that are real and some that are imaginary, I take the real ones, right, that I get from the graphing calculator. I do synthetic division till my polynomial is small enough for me to do a regular algebra solve or a completing the square quadratic formula. So I'm going to do this for you here before we go into the bigger, scarier problems. I'm going to give you a quick little reminder of something. So let's do x squared plus 4x plus 12. So what happens if we get down to this? Well, we know, quick little refresher here. Let's clear all that out. X squared plus 4x plus 12 and zoom 6. If I was to graph that, you can see it doesn't touch. It has imaginary solutions, right? Okay. So if I was to be doing this synthetic division and I actually got down to a 1, a 4, and a 12, a 1, a 4, and a 12, that would mean that this is the polynomial that you have left. Now, we knew on this one that I wouldn't have any other real ones because it only touched twice. So that means these solutions have to be imaginary, just like these ones have to be imaginary. However, I can't just solve this algebraically, right? Because now I have this linear term in here. So how do I go about doing it? You know, you have 2 possibilities. You have the quadratic formula, which when you guys were doing that on one of, or my class in 2020 was doing that on one of their last challenge problems, and a lot of people who didn't simplify the quadratic formula very well. So the other possibility is to complete the square, and that's what we're going to try right now, is both of these ones to see if we get it. Okay? So here we go. X squared plus 4x. Move the 12 off to the side like that. Remember, because we're trying to find where it equals 0. So technically, I'm not going to put it in vertex form like that. I'm actually going to put it on the other side of the equation. So let's make it a minus 12. Okay, so we'll put it on the other side of the equation, trying to solve this for the zeros. Okay, so half the linear term is 2. Put it in the square box. Square this thing in the square box. So I do a plus 4, and if I put a plus 4 on the left side of the equation, I put a plus 4 on the right side of the equation. This now factors into x with what's in the box. Squared equals -8. Root it, x plus 2 equals. Now, there's a lot going on here, but 8 is actually 2 times the square root of 2 if I simplify radical form. There's a negative underneath, so that means an I. So this is really 2I root 2 when I simplify. and it's a plus or a minus because I took the square root, which means my two zeros are negative 2 plus 2I root 2 and negative 2 minus 2I root 2. Okay? Now, I believe the quadratic formula is going to give me those same two things. Whew. Let's see. So, quadratic formula. Negative, I'll write it down. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is negative 4 plus or minus the square root of b squared. So that's 16 minus 4 times 1 times 12 all over 2. Negative 4 plus or minus the square root. 16 minus 48. Right, 16 minus 48, that's negative 32 all over 2. Okay, so quick little breakdown of 32. 2, 16, 2, 8, 2, 4, 2, 2. Twin twos, right? And if you don't remember this stuff, you can look back at one of my videos on simplifying radicals. That would be great for you. You can get that off the website too. So this would be 4 root 2. Now it's a negative, so we got to have an I. So I got negative 4 plus or minus 4I root 2 all over 2. And here's where the issue came from some of the people at home. They only divided the 2 into one of these numbers. Not both, but I need to divide it into both parts. So then you can see I get negative 2. Negative 4 divided by 2 is negative 2. Plus or minus 4 divided by 2 is 2. So 2I root 2. And you can see that that is the same as what I got when I did that over there. Okay? So hopefully that was good, beneficial for you in terms of how to be able to get this stuff. Again, this is the beginning part of 2-5, being able to create a polynomial given 3 factors. Given multiple factors, can I write out the polynomial? Can I look at what potential graphs are going to look like if I know that I have multiplicities? And can I, from here with a graphing calculator, find the real zeros, use synthetic division to get it down small enough to a polynomial that I can then use algebra with, or complete the square quadratic formula, and that's what I did right here. Now, none of these are the super big problems. I'm going to have to put those on a separate video. Those are coming up next. So hopefully this was a good benefit to you guys, a good start for this one, and we will see you later. Okay.